Hello everyone. Let me just start to talk to you about the for loop, and we're going to use the for loop. I realize I have up on the screen here is the while loop, but this is the for loop lecture. All right, so if you can just follow along with me with what we're about to talk to, I just want to recap a couple of things before we get to the for loop. We left the while loop in the last series of lectures I talked to you about. Key things you want to notice about the while loop is that there's this right here is the initialization before the loop. Now remember, there's three types of programming that we have. The first type is what? Is your sequence. Second type is what? Selection. Third type is repetition. The while loop is a repetition loop. So as and it's also a pretest loop. This is just recap where we left off from. In here is when we look at the for loop. Again, go back to the while loop. The while loop has your counter. This right here basically initialize the counter. Very important. All right. In here is your test expression. This is where you test it. You check the counter. Okay. So this was right here. You check the counter. This right here, you tell it to do some sort of statement. You need some curly brackets here to actually give it multiple statements. If there's one statement, there's no curly brackets. Same as your if-else statements in this. Very important is this line right here, is you need to update the counter. Okay, three important steps to take away from the while. First step is you initialize this counter. Second step is you check the counter, and then the last step is to update the counter. Now, from here, I want to take you to the while loops. You transform the same while loop to a for loop. Well, why is that? Well, you take whatever that's written in your initialized counter. In this case, is what? Counter with it. And I'm going to actually put over here, and my next expression is I'm going to test the counter. This is the test expression. And then separated by a colon is I need to update this counter. Okay, so all of this right here. Now let me talk about the syntax of this thing. You tell this to do something along the line in here with the while loop at this end. In this case, is to print out the counter, right? So if you look at print out the counter in this thing, so this is the print out counter with this thing. So the same two loops are equivalent. You get the same results with this thing. So here's our initialized counter, but the syntax is separated by the semicolon. Your test expression, or you're checking your counter, separated by another semicolon, and the third is you're updating your counter. So you do this while this is true. You do this, and then you update this thing. Okay, so it's kind of like a post update. You think about it. Okay, so that's what I want to talk to you about. Is the key thing is to understand that part with it before I get too far and with this thing. I want to talk to you about, for example, like I said, I've made this very, very generic. This could be C out in C++, or it could be print system out print line for Java. Same, vice versa with this thing. Let's take another example of what I just wrote down here. All right, so I'm going to move this up a little bit so we can see kind of like a little framework with what you have here right now. Take for example. Let me pause this for a moment. All right, let me talk to you about a little bit about the for loop in this case right now. All right, just the syntax of this thing. Have your parameter or initialization separated by semicolon the condition. Now this is true, this, and the update. Okay. How does this? It's true. It does, and then it updates this text by until this can become false. Let's do an example. I do for I is equal to 0, right? Assuming that I is an int and all that stuff, right? And I is less than or equal to 5. And then I'm going to update this thing. So inside of this thing, for example, I just have, how many times do you think this loop will take this iteration? How many times? What's the output for something like this? If I just did print I in this case, okay? So very similar to what we just talked about is, let's say, print I. In this case, it's your counter with this thing, right? So out here on the output after this thing, you have what? I starts in 0, plug 0 to this thing. 0 is less than or equal to 5. True. Print I. I is what? 0, right? And then you have to, your next number is what? Increment I. I's add 1 to I. I becomes what? 2. I'm sorry, 0 to 1. 1 is less than or equal to 5, right? True. So print I again. And you can see that this iteration is going to go until 4, and it gets to 5. 5 plugs 5 in this thing. 5 is less than or equal to 5. True. Print 5. This is your last value. And then increments to 6. 6 is less. So this falls out false with it. Okay? This is an example of something very, very simple with this thing. Or we could do something to modify this. Let's say if I decrement this thing. Alright? Same loop. Instead of starting with 0, we'll start with 5. And then we do 5 is what? Now, instead of less than, we just do greater than. So it just counts backward with this thing. So if I did something like this, we change to 5, 4, 3, 3, 2, 1, 0. Right? And then it actually fails out with this thing. So it just decreases as you go through this thing. Let's modify this thing another way we can actually do this. What if I took this I is equal to 0 in this, and then I took I is less than, say, 9 in this case, right? And we're going to actually do I, let's do something a little fancy out of this thing, I plus 2. Okay, so I plus 2, and you're going to output I in this case. So what do you think is going to start out with this? Take a look at this thing. Let's start something very simple. I 0 less than 9, true, right? Enter this thing, output print I. What do you think the first I is going to be? 0. Increment I, so I plug 0 into this. I plus 0 plus 2 becomes the new I is what? Is 2. 2 is less than 9, true. I'll put I. 2. Okay. 2 goes into this. 2 plus 2 is I now becomes 4. I'll put I. See where I'm going with this? And this increments up to 6, 8. What happens when we get to 8? Look at this thing. 8 plus 2 becomes 10, and then you go into I now is what? 10 is less than 9 becomes false. So it ends right where it doesn't enter this block of code right here. Okay? So something like that's very, 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 very practical, that we know the number of iteration that we can actually use with this thing. That's very important with this thing. The other part I want, let's modify some of this stuff. Let's say I is equal to 0, and let's say I not equal to 9. How's that? Remember the relational logical operator we could actually use? So not equal to 9 with the same. So what if you have this? What if you have this? What do you think of this thing? So it goes, again, the same thing, I'm just going to this better. So 2, this thing, I, 0, 0 is not equal to I, come near, out, I, 0. And then come, I now becomes what? You increment 2, right? 0 is 2, I becomes 2. And then you put I, this thing, becomes what? 2, and you continue 4, 6, 8, 10, 11, 10, 12, 13. Because of this dot right here, what happens? This leads you to what? There's a problem, folks. It's infinite loop, right? So this has become infinite loop in this thing, because never reach the end of this, making fall as fault with this thing. Remember, you want fault bullshit, so this is a very bad kind of